Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution to check whether we can travel around the circular route with the limited gas stations in it. Let's look at the problem description. We are given n gas station along a circular route where the amount of gas at the ith station is present in the ith index of the gas array. And we have a car with unlimited gas tank, and it costs cost of I to travel from ith station to I plus 1 station. So given that gas and cost array, we have to return the index of the starting gas stations if we can travel around the circular route in a clockwise direction. Otherwise we will have to return -1. Let's take a look at the example 1. So in this number of gas stations given is 5. First station has 1 unit of gasoline, and the second station have 2 units, and third 3, fourth 4 units, and fifth is 5 units. But the cost of moving from first station to the second one is 3 units of gasoline, and the second to third is 4 units of gasoline, and 5 and 1 and 2. Okay, so we have to return the index of the gas station in this array where we can start and end at the same place at the end. So in this case, if we see the available gas at the station 0 is 1, but the cost of moving to gas station 1 is 3 units of gas. So in this the net gas is -2, so we cannot move. Cost is higher than the available gas, so we cannot move to the next station. So this is not the possible starting point. Same way, so the second station, the available gas is 2 and the cost to move to the gas station 3 is 4. So we cannot move because the available gas is less than the cost to move to the next station. Same thing for the other index. Then when we come to the index 3, the available gas at that station is 4, but the cost to move to the fifth station is 1. So from here we can move to the next station. So we can set this as a starting point. And then the second one 5 minus 2. So here also we can move to the first station circularly. Okay, so right now we can start from index 3. So from here, if we spend 1 unit of gas, remaining 3, and we move to the next station, and from there we move to the first station after spending 2 units. So there we have additional 3. Totally we have 6 units of gas. And then from 1 to 2, when we move, we have to spend 2 units of gas. And then from 2 to 3, we need to spend 2 units of gas, and then remaining 2. And then from 2 to index 3, we have to spend 2 units of gas. So when we start from the index 3, we can go around and come back to that place. Output is 3. So here in the next example, the 0th station, the cost of moving to the next station is higher than the available gas. So this is not the starting point. Then the next station 3 minus 4, that is also less than 0. So this is also not the right station. Then 4 minus 3, this probably the starting point. So here we have a left 1 unit of gas left, but when we come back here 2 minus 3, so we utilize that remaining 1, but from here we cannot go to the other station. So I mean from here we cannot go to the second station. So in this case the output is -1. Gas and cost array length is n, and the n is ranging from 1 to 100,000, and the values in the gas and cost array is ranging from 0 to 10,000. Let's look at the approach to solve this problem. So we are given this input array, the expected output is 3. So we can solve this using a pattern matching with a single pass approach. So in this case the pattern is to find the first entry in the array wherein the difference between the gas entry and the cost array entry is greater than or equal to 0. So only from that entry we can start that circular traversal. So first we initialize the total gas available variable to 0 and the current trip gas to 0. So the purpose of this variable is to keep track of the total amount of gas available from the entries we have traversed so far. But the current trip gases, it accounts from the entry where we are actually started the journey. For example, if we start in the index 2, so the current trip gas variable contains the available gas starting from this entry, not from the beginning. Total gas available variable contains the gas available with all the entries starting from the index 0. We traverse the array and find the difference between these corresponding entries, and whichever entry the value is greater than or equal to 0, we mark that as a starting point for the circular traversal, and then we keep traversing until the current trip gas is greater than or equal to 0. If it is less than 0, then immediately we reset the current trip gas to 0 and update the starting point to point to the next entry in the array. Because we cannot proceed the journey, there are no enough gas available. So we are abort the journey and start from the next entry. Okay. So when at the end of the traversal, the start variable contains the starting point if there is any in the array, and then in addition to that we have to check whether the total gas available is greater than or equal to 0. If it is less than 0, then we mark the starting point as -1, because the total gas available in all the gas station is less than the total cost to do the circular trip. So in that case we set -1 to the start index and return. Let's look at the flowchart. Input for this procedure is two arrays, gas and cost. First we initialize the total gas available and current trip gas and the start variables to 0. Then we enter the for loop to process all the entries in the gas array. First we check whether we visited all the gas stations. If not, we compute the difference between the entries in cost and the gas array pointed by the IDX pointer, and compute the net gas in that station, and we add that net gas value to both the total gas available as well as the current trip gas variable, and we check whether the current trip gas variable is less than 0. That means the amount of gas available so far is less than the cost of moving to the next station. So in that case we have to reset the starting point of the circular traversal. So we update the starting pointer with the value idx plus 1. Basically we move to the next entry, and then we reset the current trip gas. If that value is greater than or equal to 0, then we proceed to the next station. So once all the stations are visited, then when we come out, we check whether the current trip gas is less than 0. That means the total amount of gas available in all the stations is less than the cost of moving from one station to the other. So in that case it's not possible to make a round trip. So we set the starting point as -1 and we return that starting point. Otherwise, whatever the station from which we can make a circular trip will be set in the start variable in this loop. Let's move on to coding. First I initialize the total gas available and the current trip gas and the start station to 0. Then I write the for loop which iterate over the gas array. Each iteration I compute the net gas by subtracting the entry pointed by the IDX in the cost array from the entry pointed by the IDX in the gas array. Then I added the net gas to the total gas available as well as the current trip gas variables. Then I check the current trip gas whether it is less than 0. If so, we do not have enough gas to move to the next station, so we abort the current trip and start the trip from the next station. So I set the start variable with the value idx plus 1 and then I reset the gas, current trip gas. At the end of the loop, I check whether the total gas available is greater than or equal to 0. If it is less than 0, that means the total amount of gas available is not sufficient to move around. So I set the start variable with -1 and finally I return the start. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given these two arrays. The expected output for them is index 3. So starting from index 3 we can make one circular trip. So first we initialize the total gas and the current trip gas to 0 and the starting station is set to the 0th station. Okay, so start is pointing to the 0th station, IDX is pointing to the 0th entry of both the arrays. So next we entering the for loop. So in the iteration 0, when we enter the loop, the net gas is 0, total gas available is 0, current trip gas is 0, starting station is 0. In the body we compute the difference between these two entries, which is -2, the net gas is -2, and we add that value to the total gas available variable as well as the current trip gas, but we check whether the current trip gas is less than 0. In that case we update the starting station to the next station, idx plus 1, and we reset the gas to 0. So that's why we see 0 here. Otherwise if it is a positive we would have seen that accumulated here. So the starting station is moved to a next entry. Okay, then in the iteration 1 we find the difference between these two. Again the cost is higher than the available gas, so the net gas is -2 and the total available gas when we enter the loop, we enter this iteration is -2, but when we add that it becomes -4. Because the difference is -2, we reset the current trip gas again to 0 and we advance the start pointer to point to the next station, which is at index 2. Then in the iteration 2 we again compute the difference between these two. Again it is negative. We add that to the total gas available, so that becomes -6 and we reset the gas current trip gas to 0 and advance the starting station pointer to point to the index 3. So it is pointed at index 3. Next on the iteration 3 we compute the difference. In this case the gas available is more than the cost to move to the next station, so that's why we see the net gas as 3, and then the total gas when we add it to the when we add the net gas to the total gas it becomes -3 and the current trip gas is 3 and the starting point is not modified because it is greater than the net current trip gas is greater than 0. Then in the iteration, so the starting point, starting position for this circular trip is not altered, so it still points to index 3. And then we come to the last iteration. When we compute, in this case also the available gas is more than the cost to move to the next station, so we have 3 extra units of gas, so that's why we see net gas 3. And when we leave this iteration, so the total gas, when we add it, it becomes 0, and the current trip gas is 6 units available, and then the starting point is 3. Okay, so after coming out of the loop, we check whether the total gas available is less than 0, then we update the starting point to -1, but in this case it is 0. So that means we are able to complete the circular traversal, and then we return the 3 as the return value. So the 3 is the expected output. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. For this input, let's see how many iterations this for loop runs. For this input, it runs 5 times. That is equal to the length of the input array. So for n number of elements, this for loop runs n times. So the time complexity for this solution is order of n. And with respect to the space complexity, we are not allocating any additional space with respect to the size of the input. Instead, we just use a few variables, so the space complexity is order of 1. Thanks for watching this video. Have a great day.